Hello students! Welcome to our video tutorial in Mathematics 9. For week 6 and 7, we will discuss about similarity. And how do you define similarity? Notice that the root word of the word similarity is the word similar. Now, is it necessary for the two or more objects to have the same shape and size in order for them to be similar? Now, we will learn more about similarity in this video. Let me show you first the flowchart of our discussion. So, when talking about similarity of polygons, so we are going to talk about right triangle similarity and triangle similarity. Now, in right triangle similarity, we have here two special right triangles. We have the 45, 90 degrees theorem, right triangle theorem, and 30, 60, 90 degrees right triangle theorem. And in triangle similarity, we will talk about, or maybe you have already an idea about this similarity. So we have here the Sss similarity, or the side angle side similarity. We have here the SSS similarity, or side similarity. And the third one, we have the ASA similarity, or angle side angle similarity. So how do we define similar polygons? Similar polygons are two polygons with the same shape but not necessarily of the same size. The symbol for similarity is this one. So if you see this symbol, this is the symbol for similarity. When two polygons are similar, the corresponding angles are congruent. Angles are congruent, and the corresponding sides are proportional. Okay, let me show you an example of similar polygons. So we have here three sets of examples of similar polygons. Now, in letter A, you have there a rectangle. So, the two triangles are similar. They have the same shape, but they don't have the same size. The same in letter B, you have there the two stars, the small one and the bigger one. So, they have the same shape, but not of the same size. The same also with letter C. We have here two triangles. Now, the other triangle, or the two triangles, are not of the same size, but they have the same shape. Now after this, I'll be giving example with measures so that we can be able to identify the corresponding angles that are congruent and the corresponding sides that are proportional. So, we have here example. Quadrilateral hope is similar to quadrilateral star. So, we have here hope, H-O-P-E, with the corresponding measures in each sides, and in each side rather. And we have here quadrilateral star, S-T-A-R, with the corresponding measure of each side. Now, if the two quadrilaterals are similar, we are going to identify the angles now that are congruent. So first, as you can see, you have there angle H. Angle H is congruent to angle, what angle? Angle S. Okay? Then, angle O. Angle O is congruent to angle, what angle? Angle T. And angle P is congruent to angle A. As you can see, na-assign diha nga nagpakita that they are congruent. Then angle E is congruent to angle E is congruent to angle R. So, since the corresponding angles are congruent. So that is one qualification that the two quadrilaterals are similar. Now, if the angles are congruent, at this time, we are going to identify the sides that are proportional. Now, let's have first HO. Let us identify first the sides that are proportional. We have HO is proportional to ST. And would that be equal to the other side that is proportion also to each other? So we have OP is proportional to side TA. And another side is side PE. PE is proportional to side AR. And lastly, we have side EH. EH is proportional to side RS. Now, shall we substitute the value for each side so that we will know that these sides are really proportional to each other? So, what is the measure of HO? So, you have there, HO is 5 over your ST, which is, what is the measure of ST? You have there 10. Then you have OP, which is 8, and TA is 16. Then PE is 9 over AR is 18. And EH is 3 and RS is 6. Now, can we say that 5 over 10, 8 over 16, 9 over 18, 3 over 6 are equal? Now, if we are going to reduce all of these fractions or ratio or that show proportionality, simplify them to lowest term. What is their value? Very good. They are all equal to 1/2. Okay? So, since all the sides that are proportion to each other measures 1/2 or 1:2, therefore, the corresponding sides are proportional. Okay? Now, what is the scale factor? If we have here 3, how did we get 6? Meaning, we multiply 3 with 2. So, 3 times 2, 6. So, to check if other parts of polygons are really proportional, you will also multiply the other sides by 2. So, you have here 5 times 2, you have 10, 8 times 2, 16, 9 times 2, 18. So, therefore, their corresponding sides are proportional. Now, let's have the triangle similarity. So, first, we have here angle-angle similarity postulate. Now, it states that if 3 angles of one triangle are congruent to 3 angles of another triangle, then the 2 triangles are similar. Now, in here, I'm not going to show you the proving of the theorems because it is already shown in your module. So, I will help you in this video on how to identify the parts that will guide us to identify what similarity theorem that we are going to apply. So here we have here the angle similarity. Now we have here 2 triangles. We have triangle ABC and triangle DEF. Now as you can see, the parts that are congruent, naa siya symbol, no, this one. So meaning to say that angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F. Now, if the three angles of one triangle are congruent to the other three angles of another triangle, therefore, the three triangles are similar. So, therefore, we can say that triangle ABC is similar to triangle DEF by applying the angle similarity postulate. So if there are problems like this you encountered, especially about similarity, you better label the parts so that you will be guided kung asa nga part nila ang congruent, asa ang lain nga part nga proportional, para dili mo maglibog. So you label the parts that are congruent. And we have here angle or AA similarity theorem, which states that two triangles are similar if two angles of one triangle are congruent to two angles of another triangle. Now we have here triangle LUV and triangle WHY. Now we are going to identify the angles that are congruent for us to say that the two triangles are really similar. Now, again, I will not show you the proving. But we're going to identify the parts that shows congruency. Now, naa siya'y sign or symbol nga nag-indicate the angles that are congruent. So, in this triangle LUV, so we can say that angle U is congruent to angle H. Then angle V is congruent to angle Y. Can we say that angle L is congruent to angle W? Now, according to the theorem, it states that if only two angles are congruent to the other side, then the two triangles are similar. Now, we will give exact measure for each angle, then we will find the measure of angle L and W to make sure if they are really congruent. What if we say that angle U is 55 degrees? So that means that your angle H is also 55 degrees because they're congruent. And shall we say that your angle V measures 60 degrees? So that means your angle Y measures also 60 degrees. Now remember that the sum of the measures of the three angles of a triangle is 180 degrees. So if this is 55, this is 60, so how much is the measure of angle L? So this measures 65 degrees. What about measure of angle W? So it measures 65 degrees as well. So now we prove that angle L is congruent to angle W. So therefore the two triangles, triangle LUV is similar to triangle WHY. That is AA similarity theorem. So we have SSS similarity theorem. Two triangles are similar if the corresponding sides of two triangles are in proportion. Now, we have here triangle Earth and triangle Sky. So, how do we determine the corresponding sides of the two triangles for us to show that they are really similar? Now, in this kind of triangles are right triangles, so meaning angle R is right angle rather, then angle K is also right angle. Now, can you identify the corresponding sides of the two triangles that are proportion? So we have, okay, shall we do it together? So we have their side ER. Side ER is proportion to this side is proportion to SK. And that would be equal to RT, side RT, so nagsugod ka sa right angle, RT is proportion to KY. And the third one, you have there, side ET is proportion to side SY. Now, to make sure if they are really proportional to each other. Now, what if I would say that this is 9, this is, I would say this is, sorry, this is 4. What if this is 4, this is 5, and this is 9? Now, considering that the two triangles are similar, now, can you give the measure of this triangle so that they will be proportion to the given measures of triangle ERT? Now, if this ER is 4, this is 5, and that is 9, what would be the measure of SK, KY, and SY? Okay, for example, if I would say that this side is 15, okay, if I say that KY is 15, now how long is your SY and SK? So remember that RT correspond to or proportion to YK. So try to check how much did I multiply to 5 so that I got 15. So you have here 3. So therefore the scale factor is 3. So meaning to say, the number that we multiply 5 nga nahimo siyang 15, what that would be the same number nga i-multiply na to sa 4 ug sa 9. So 4 times 3, that would be 12. So unsa man nga part ang kuan sa ER? So that is SK, so 12. And ET is 9. 9 times 3 is 27. So SY is 27. So if we're going to substitute the value ER, that is 4, SK is 12, RT is 5, and KY is 15, and ET is 9, and SY is 27. Reduce them to lowest term. How much do we get? So they are all equal to 1/3. So therefore, we can say that triangle ERT is similar to triangle sky. We have here the Sss Similarity Theorem, or side angle side. It states that two triangles are similar if an angle of one triangle is congruent to an angle of another triangle, and the corresponding sides, including those angles, are proportional. Now, let us consider these two triangles. We have here triangle RAP and triangle MAX. So we have here triangle RAP. AP and triangle MAX. Now, with the indicated symbol there or sign, we can say that RA is similar or proportion to MA. And what else? And XA is proportion to PA. So we are going to identify the condition that will satisfy that this two triangles shows Sss Similarity Theorem. Now, can you identify the angle that is considered as including or included angle of the two sides that are proportion? What angle is considered or are considered as included angle? So we have this and this one and this one. So asa di ang angle nga napatungan sa duha ka sides? So we have this angle. This angle is congruent to that angle. So therefore we can say that angle RAP is congruent to angle MAX. Now, since the two sides here are proportional to each other and the included angles are congruent, therefore we can say the triangle RAP is similar to triangle MAX. That is by side angle side similarity theorem. We have here 45, 45, 90 degrees right triangle theorem. It states that in a 45, 45, 90 right triangle, each leg, which is represented by small letter L, is square root of 2 over 2 times the hypotenuse H. And the hypotenuse H is square root of 2 times each leg L. So in short, your hypotenuse H is equal to square root of 2 times the measure of leg. And the measure of your leg is equal to square root of 2 over 2 times the hypotenuse. Now we have here a right triangle, a 45, 45, 45, 45, 90 degrees right triangle. Now the side opposite your right angle here, this is the hypotenuse, or represented by letter H. And the two other sides here, these are the legs. So these are the legs. Okay, since they are both 45 and this 45, meaning the length of the two legs are equal. Okay, now to solve for your H, that is diretso na siya, though we can find the measure of each side using Pythagorean Theorem, but the shorter way is to apply this 45, 45, 90 degrees right triangle, because they are special right triangle. So simply multiply square root of 2 to whatever measure of the given legs here. So that is L. And to solve for your leg, that is square root of 2 over 2 times whatever the value of your hypotenuse. Okay, let's have an example. Okay, we have here three examples. Now, in number 1, we have here 45, 45, 90 degrees right triangle. So the given value here is 3. That is the leg. So we have to find for the value of our H or hypotenuse. So remember that to solve for your H is equal to square root of 2 times the value of your leg, or the measure of your leg. So simply substitute. You copy square root of 2 times, you enclose it with parentheses, times 3. Now you simplify. Since 2 here has a radical sign and 3 is just a constant, no radical sign at all. So you multiply square root of 2 times 3. So maguna na ang 3, then itupad si square root of 2. So, this is now the value of your hypotenuse. Okay, so very simple. Now, in number 2, you have here, the given measure is 6, which represents the hypotenuse. So, which means that we have to find the measure of your leg, So, remember that to solve for the leg is equal to, what is the formula? Square root of 2 over 2 times the hypotenuse. So, again, you simply substitute. You copy square root of 2 over 2 times the hypotenuse, which is 6. Now, you simplify. You can apply here cancellation method. You can cancel 2 and 6. You can divide 6 by 2, or para di mo maglibog, ato ning i-multiply ang 6 sa square root of 2. Remember that your 6 here, this is over 1. So, therefore, you have here 6 square root of 2 over 2. To simplify, we can divide 6 by 2. So, 6 divided by 2, so you have there 3. And copy square root of 2. So, therefore, our leg measures 3 times square root of 2. Okay? Then, number 3, the given here is 5, which is the hypotenuse. So, we are going to solve for the leg. So, again, your leg is equal to square root of 2 over 2 times the hypotenuse. So, substitute. So, you have 2 over 2 times 5. Okay? Then, you simplify. You multiply 5 with square root of 2. So, you have 5 times square root of 2 over 2. Now, can we divide 5 by 2? Okay, so, therefore, the final answer is this. So, 5 square root of 2 over 2. That is the measure or the length of our legs. Another special right triangle is the 30, 60, 90 degree right triangle. Now, in this kind of right triangle, we have a shortcut way of finding the length of the shorter leg, longer leg, and the hypotenuse. Now, in this given right triangle, 30, we have here 30, 60, and 90 degrees. Now, how to identify if that is the shorter leg, longer leg, or the hypotenuse? Now, the side opposite your 30 degrees, that is the shorter leg. And the side opposite your 60 degrees, that is the longer leg. And it is always that the side opposite your right angle is the hypotenuse. Now, to find for the shorter leg, if the given is the hypotenuse, if the given value is hypotenuse, to find for the shorter leg, that is 1/2 of the hypotenuse. So, meaning hypotenuse divided by 2. Okay. Now, the longer leg L is square root of 3 times the shorter leg. And to find for the hypotenuse, that is twice the shorter leg. So, bali siya ang hypotenuse, kaduhaon niya ang length sa shorter leg. Then, to solve for the shorter leg, that is 1/2 of the hypotenuse. Now, what if in finding the shorter leg, ang given kang ang value sa longer leg? So, we are going to use shorter leg is equal to square root of 3 over 3 times the longer leg. Okay, so to understand better, let's have this example. So, let us answer these examples. Number 1, you have here 30 degrees given, and the opposite side to it measures 8. So, since the given length is opposite of 30 degrees, that means that your 8 there represents the shorter leg. So, we have to find for the longer leg and for the hypotenuse. So, let us find first the hypotenuse H. So, your H is twice. Sa ganito ang h, your h is twice the shorter leg. So meaning you have there 2, then multiply it with 8. So therefore, your h is equal to 16. And to find for the longer leg, remember that to find for the longer leg, that is square root of 3 times your s. Then substitute the value of s, which is 8, or square root of 3 times 8. So iuna ang 8, then itupat si square root of 3. So therefore, your longer leg is 8 times square root of 3. Okay, that's it. For number 2, the given measure here is the side opposite your 60 degrees. So therefore, this is the longer leg. So we're going to find for the hypotenuse and for the shorter leg. Okay, so to solve for we cannot solve for the hypotenuse unless we have the length of the shorter leg. So let us solve first for your shorter leg. Okay, remember that shorter leg is, since the given is the longer leg, so we will use square root of 3 over 3 times the longer leg. Okay, so substitute. So we have square root of 3 over 3 times 9. Okay, now we can apply cancellation method here. We can cancel 3 divided by 3, that is 1, and 9 divided by 3, that is 3. So square root of 3 times 3, so that would be 3 times square root of 3. So since 3 becomes 1 already, therefore our shorter leg is 3 square root of 3. Okay, then to find for the hypotenuse is twice the shorter leg. So hypotenuse is equal to twice the shorter leg. So substitute. So 2 times 3 square root of 3. So you multiply 2 with 3. 2 times 3, that is 6, and just copy square root of 3. Therefore, the hypotenuse is 6 square root of 3. Okay, for number 3, we have here the given length is the measure of, what side is this? This is the hypotenuse. So we are going to find for the shorter leg and for the longer leg. So since we have here 30 degrees, so this is our shorter. So understood, this is 60, so this is our longer leg. Okay, now to solve for your s, remember that your s is 1/2 of your hypotenuse, or that would be equal to 10 over 2, which is equal to 10 divided by 2. So therefore your shorter leg is 5. Okay, what about the longer leg? How do we solve for the longer leg? Longer leg is square root of 3 times the shorter leg. Okay, so substitute. So you have square root of 3 times 5, which is the shorter leg. So square root of 3 times 5, so iuna na to si 5. So that would be 5 times square root of 3. So that is now the value of your shorter leg. I hope you learned something from our video about similarity. So just keep on practicing and always believe in yourself. Dahil sa math, ang buhay ay aangat. Thank you for watching.